The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody, and good morning or good afternoon or even good evening for the people in the Far East. My name is Sander Selten. I'm a marketing manager for specialty agriculture in ICL Specialty Fertilizers, working from the Holland office. We are very pleased that everybody is joining this technical webinar on H2Flo. At this moment, I'm the only one talking, and I have muted all the participants, because if we would unmute all of you, it creates an incredible noise. So we would like to keep the line muted. We have a huge number of attendees at this moment. We will start in a few minutes the presentation on H2Flo. Gary Atkins will present this. During the presentation, after each section, we have built in time to ask questions, and we would like, if you have a specific question, we will pause for a moment. If you have a specific question, please ask your question via the chat, which you see in the control panel on your right at the bottom end. There, at this moment, you also see in the chat area a text saying welcome to the ICL's technical training on H2Flo. So there, I hope that is clear for everybody. There you can ask your question. So if everybody can see it, I will type a question now, and I hope that is visible for everybody. Good. So it's a few minutes past 10, so I suggest that we start at this moment. So welcome again to everybody. That means we have many ICL Specialty Fertilizer employees, area sales managers on the call. We have many partners from our dealer and distribution network, so a special welcome to that. And I guess we also have specific end users who are calling in, so also to you a very welcome. So Gary, next slide please. So the agenda on today's call, we would like to have this session taking not longer than 1 hour. We will, of course, the main topic is H2Flo. So what is the background? What is a surfactant? How does a surfactant works? We have some interesting trial results which we want to show you. Then at the end, again, there is time to ask questions, and we should be ready around 11 o'clock. So again, my name is Sander Selten. I'm a marketing manager at ICL Specialty Fertilizer, and Gary Atkins, product manager global for H2Flo, working from the UK facility. Next, Gary. So as everybody know, we as ICL, we have a very extensive portfolio in plant nutritional products. Within Spec Ag, you see here a number of brands on the left side. Since 2014, we have also other products in our portfolio, of which H2Flo is one of them. And we start with these products in our portfolio because we think that they can really enhance the fertilizer effectiveness. So this is the first product we will introduce. There will be many more to come. Next slide, Gary. And this portfolio from our plant nutritional products will be, let's say, enhanced with products coming from Amiga. Amiga is a UK subsidiary of ICL. We acquired that company in September 2014, and they are specialized in water conservation and nutrient enhancement technologies. And there is a large portfolio of wetting agents, specialty liquids, adjuvants, seaweed extract, trace elements, seed treatments, amino acids, and biostimulants, which we are at this moment already selling in the turf and landscaper market, in the ornamental horticultural market, and today we will focus on the specialty agricultural market. But we are pleased as ICL that within our range of production facilities, we now have this UK-based facility, which are the experts in surfactant formulation and in technology. So I would like to pass the word now to Gary Atkins, and he will guide you through the presentation.
Thank you, Sander, and good morning or good afternoon, everyone. So my name's Gary Adkins, and I'm the H2Flo product manager. So firstly, I just want to explain what is H2Flo. So H2Flo is a liquid product that is applied to the soil via the irrigation system, which allows growers to maintain or increase the yield while cutting their water rates. It allows for maximum efficiency of applied water to the crop. And H2Flo uses a blend of surfactants to improve both penetration and lateral, so sideways, movement of the water within the root zone. Combined with this is a root activator, and this is there to promote an increase in the root mass. And H2Flo is the product for specialty agriculture, so it's been formulated and designed specifically for this market. So before we get too far into the product, I want to do a small background on what is a surfactant. So the definition of a surfactant is a compound that lowers the surface tension or interfacial tension between two liquids or between a liquid and a solid. So surfactants are a class of chemicals that cause a physical change at the surface of a liquid. And the surfactant actually stands for surface active agents, and it's just shortened down to surfactant. And these changes occur where there's an interface between two different liquids, or a liquid or a gas, or a liquid and a solid. An important point to make is that wetting agents are surfactants. So you'll hear the term used a lot. What is a wetting agent? What is a surfactant? They're both the same. So the wetting agent is just a marketing name for surfactants. So the two terms are interchangeable. So surface tension. So at the most basic level, the way a surfactant works is it lowers the surface tension of a water or of a liquid. And a lower surface tension allows the water to spread across a larger surface area by reducing the contact angle. So this is where if you have a bead of water on a surface, it will form a sphere. If you add a surfactant, that will help to lower the surface tension and allow it to cover a greater area, reduce the contact angle, and increase the coverage. The next point to make is on water chemistry. So water is dipolar. This means it has both a positive and a negative end. And water will not bond with non-polar molecules, such as oil. So if you add oil to a water, it just sits on the surface and moves to the surface. So the two things cannot be combined together without the use of a surfactant. If we look in more detail at the way a surfactant is structured, you have two parts. So you have a head and a tail. The head part is a water-soluble group, so it's hydrophilic or polar, and you have a tail part which is oil-soluble, which is non-polar, which is lipophilic. So you can see that one end can attract to water and one end can attract to oils. And the way these surfactants work is they form a bridge or a link between the water and something that's hydrophobic, so maybe an oil, or in the case of soil, a buildup of organic matter. So what they do is they allow the water then to not be repelled anymore, so it doesn't just sit on the surface, it can penetrate into the soil, and it can form like a bridge or a link between the two. So the non-polar portion of the surfactant bonds with the non-polar part of the oil, and the polar part binds with the water, and therefore you allow hydration to occur within the soil. Now, there's lots of different types of surfactant, and they're classified into 4 main groups based on the charge that they carry. So there's a non-ionic, which has no charge, anionic, which is a negative, cation, which is a positive, and zwitterionic, which has both a positive and a negative. This is important because non-ionic surfactants are the ones that are most suitable for plant application. The issue with using a charged surfactant is that they can react with other ions within the solution, the water, a liquid fertilizer, for example, and they can cause big problems with precipitation or foaming to form. Non-ionic surfactants also work well in acidic conditions. The problem with using a charged surfactant here is it can react with calcium, magnesium, ions within the water and cause problems with that. The other key part for non-ionic surfactants is they have a low toxicity profile, so they're safe to use on plants. So that's the first section on surfactants. Fairly basic, and I realise a lot of you will know a lot of that information already, but I think it's good just to outline exactly what a surfactant is and what the basic principles are. I see that there's no questions on this section, so I will move on to the next part.
Gary, at this moment there are no questions. So once again, if people have questions, please write them down in the chat box, which you find in the right bottom of your control panel.
Okay, thanks, Sander. So moving on, this is how, in principle, H2Flo works. So this is a coir or coconut, and you can see this is just water on its own being added to the coir, and you can see it's running off. In some parts it penetrates in, but a large amount of the water is pooling to the side. Now we add water with H2Flo. And you can see it instantly expands the coir. You can see how it's sucking in the water from the previous standard application. And you can see how quickly the coir became fully hydrated versus with water alone. This next picture also shows you how H2Flo works. So this is a dye test. So this is where just a blue dye was added in with the water and the H2Flo. And these photos are of a standard raised bed cut into sideways. So you're looking side on at the bed. The top picture shows you can control. So there's one drip tape, and this is after 1 hour. And you can see across the bed there was a 31% coverage, so where the actual water reached was only 31%. However, when you added H2Flo through the drip system, after 1 hour, you had achieved 52% coverage of the bed. So you can see it's allowing the water to move sideways and into a far larger area of the growing media. This slide shows you H2Flo in the field. This is taken from some work done in California. And the issue they had here was that it had a surface drip emitter, and the problem was the water was just running off the side of these raised furrows, and it wasn't going down quickly enough into the soil, so they were having to put on a huge amount of irrigation water to try and wet up the soil. So you can see the untreated, even after 3 weeks of irrigation, you can see where the water is going. It's not going at all where they want it to. It's nearly all going down to the right of the picture there, off the furrow. As you can see with H2Flo, after just 3 hours of drip, the water is going far more centrally and immediately into the soil, and you get a much more uniform distribution of your water. So those last 3 slides showed you how H2Flo is working in practice. If we look at the chemistry, H2Flo is a blend of multi-block polymer surfactants, so it's 88% active material. The rest of the product is made up of water and preservatives, the remaining 12%. As I mentioned earlier, it's a non-ionic surfactant, which means it's very safe to plants, and it is compatible with a wide range of fertilizer chemistry. The key to the product is that it has a long-chain surfactant system, and what this means is that the long chains, they break down gradually over time through microbial activity within the soil, and they give a residual activity. So it's not just a one-shot penetrant. It doesn't work just the first time you apply it through the irrigation system. It remains within the soil, and it works with every subsequent irrigation event. H2Flo also includes a root activator. So this is a root activator based on, again, on surfactant chemistry. What we've found with work carried out is that it can stimulate root production, and it can create a greater root mass. So the plants treated with a root activator on its own, they show increases in both secondary roots and the root hair number in comparison to the untreated roots. So it's not necessarily the root length, the larger tap or primary root, it's the smaller root hairs. And these root hairs are the ones that are key for uptake of nutrients, water, as these have a very large surface area, so they can take up a lot of nutrients or water versus a single large root. And the work we did gave untreated an average of 22 root hairs per centimetre of root, whereas with root activator this increased dramatically, and there was an average of 236 root hairs per centimetre of root. And this is what that looks like under the microscope. So you can see the untreated roots. There's a very small number of root hairs, some secondary roots, but very limited. Whereas we look at the treated roots after 28 days, you can see this huge number of very fine root hairs, greatly increasing the surface area of the root. So who should be using H2Flo? Well, it's any grower who's using a micro or drip irrigation, fertigation system, and anyone with any water restrictions or limitations on the water. So that might mean that there's water available, but it's very expensive. It might mean that there's a limit to the water that you can use. It might just mean that the water isn't going where the grower wants it to go within their field. We're also looking at the non-irrigated field crops, so this is an area we're expanding into. There's a lot of work planned this year, especially with potatoes. This is where we can go in with a sprayer application rather than through the irrigation system. The main market will be the sandy or lighter soils, as this is where the water issue is going to be the greatest. But the product is not limited to working only in sandy soils, and we've actually seen some very good effects on heavier soils in some of the markets where the product is already being used. And then in terms of the crop, well, it's a wide range of crops. It's strawberries, tomatoes, peppers. It's all of that list. It's anyone who's growing anything under irrigation that has issues with their water. How is the product applied? So this is the application details. So the timing, you should be applying it pre-planting or at transplanting, or when you're wetting up your growing media at the start. So the best time to apply is at the start of the crop cycle. The application rate, we have a range, and the reason for that range is that you do have different conditions. So the standard rate would be 1.2 litres per hectare, but we can go up to 2.4 litres per hectare if we have very dry conditions, very, very hot conditions, soil that's in a very bad condition for that first application. You can go out at a higher rate. And then we have monthly applications at half of this rate, so between 0.6 and 1.2 litres per hectare. The application methods, as I mentioned, through the drip, centre pivot, overhead irrigation, first application prior to or close to planting. Subsequent applications should be made on a monthly basis. So for example, for a 12-week strawberry crop, you'd make an initial application of 1.2 litres, and then monthly applications at 4 and 8 weeks of 1.2. So you'll be looking at a total of 3.6 litres a hectare for that 12-week crop. So are there any questions on that section so far?
Yes, Gary, we have a question from Italy, from Marco Santellini. And Marco, you are now unmuted, so you can speak. Or I can ask the question as well. The question, Gary, from Marco Santellini is if we have data on a use of H2Flo on the rooting phase of micro-propagated plants. And Marco Santellini, you are now unmuted, so you can perhaps explain your question more in detail.
Hello, Marco. Have you got a question?
Yeah. Yes. Are you listening me?
Yes.
Yes, I can hear you.
Okay, perfect. I spoke with this product to nursery, a big factory of nursery plant that produce plant by micropropagation. So they are interested to trial this product in a particular phase of their process. When the plant asks from the laboratory, they put this plant without roots in a growing media that can be peat or peat moss. So they requested if the product can be give some problem in this phase when the plants are really small.
Thank you for the question. No, it won't give any problems at that stage. We do have a lot of work and a lot of experience with using the product with newly transplanted or plants that are growing straight from seed, and we have no issues in terms of toxicity on the very small new roots. We'd recommend there that you probably only need a low application rate, so probably the half rate. So maybe just start off with the 0.6 litres per hectare rate and ensure that you have sufficient water at the time of application.
Okay, Gary, there is another question from Mark Davies. And Mark, you will be unmuted now as well. So you can talk if you want. The question, Gary, is how does the use of H2Flo affect the chemical behavior of coir substrate post-application? And will we see a buildup of EC and less steerable media?
Okay, so that on that point, what we've actually seen is the opposite of that. So where we've been using it within the Koya, we've found a more stable EC balance across the media. So it doesn't just allow water to sit and pool within the Koya, it allows it to move out sideways, it allows it to penetrate through if there's excess water. So all of the work that we've done so far with Koya has shown that it's very beneficial to the EC levels and having a stable and uniform EC level within the media.
Okay, then the last question for this section is from Kenneth Lim. And the question from Kenneth is, will surfactants create foaming problem in underground water?
Well, all surfactants do create a degree of foam due to the nature of it. H2Flo does have some, part of the inert ingredients is a anti-foam, does have some anti-foam properties in there to limit this. So far, in all applications we've used in the UK and the US, we've had no issues with foaming, and we've also done a lot of customers using the large bulk product and repacking down to smaller pack sizes, and again, no issues with foaming. So I would suspect that we won't have any problems.
Okay, so I suggest we continue also for time reason, Gary. Other questions can be asked later on.
Okay. So now what I want to do is just pick out some of the trial work, some of the most recent trial work, and just talk you through that because we've got some very interesting and exciting results. So the first one we're looking at here is a trial on squash, which took place in autumn 2015. And these photos just show you the field setup, so you can understand how the squash has been grown and how it was being treated. So this is the summary slide. Now the presentation will be available, so I'll go through this, but if there's on any of these trials, if you want more details, the full reports, I'm sure we'll be able to provide these. These are just quick summaries for this presentation. So we're looking at squash or pumpkin. The type was crookneck yellow. This was from a commercial field in Brooksville, Florida. And what we were looking to do was show that H2Flo allowed you to reduce the irrigation volume and maintain or increase the yield. H2Flo was applied via the drip irrigation system. There was two irrigation system programs used here, so we were looking at 100% irrigation and a 70%. Now these irrigation programs were taken using the reference ET, so that's the envirotranspiration. So that shows that's the amount of water that the area needs, taking into account the crop coefficient. And based on those figures, it was approximately 20,000 litres per hectare a day. And H2Flo in this case was applied at 1.2 litres a hectare at transplanting, and then it was applied at 1.2 litres per hectare at weeks 1, 2 and 4, so there was an equivalent of 4.8 litres a hectare applied in total. The measurements taken, we looked at the soil moisture, so this was taken at the bed centres at 13 centimetres deep with a TDR, which is a type of soil moisture meter, and these readings were taken before the first irrigation cycle every morning. And then we looked at the early and total marketable fruit weight. So the early was the first two harvests, the total was all 4, and we carried that on each week starting 5 weeks after the first treatment was applied. And the results that we had here were fantastic. So our best treatment results, which you'll see in a moment, we managed to achieve an increase in yield of 29%, at the same time giving a 30% water saving. And in terms of return on investment, there's a very clear positive here. So the approximate cost of that 4.8 litres of product of H2Flo was 96 euros per hectare, and the yield increase that we achieved was equivalent to adding an extra 626 euros per hectare. So you can see there was a clear positive of 530 euros plus, as we'll go on on some of the other slides, the savings in terms of time and money in the actual water that was used. So this first graph shows you the average moisture at the center of the beds 13 centimeters down. It's as a percentage, and you can see that the non-treated, so that's just water on its own at 100% irrigation level, so ETC, which is the potential crop envirotranspiration. So this is 100% irrigation, was running at 13%. And if you reduce the water by 30%, but also added H2Flo, you could actually increase that moisture level slightly. So we were managing to have very similar or slightly more moisture, even with 30% less water applied. Now this next slide shows you the total fruit weight, and it's in kilos per plot, so kilograms per plot, and it's a total, so all 4 of the harvesters added together starting after 5 weeks after the first treatment. And what you can see here is that the non-treated, so the 100% irrigation, water on its own, was running at 7.9 kilos per plot, whereas with the H2Flo and only 70% of water, we went up to 10.2. So there's a 2.3 kilo per plot increase, so that's around a 30% increase. So not only did we save 30% of water, we also added almost 30% yield. The next trial I want to talk about is a citrus trial, which was run in the summer of 2015. Again, just some photos to show you the trial situation and how the trees were actually being grown here. So we're looking at citrus orange, Hamlin variety. Again, this was in Florida, another part of Florida, so Lake Wales. And the objective again was to show that we could reduce the irrigation volume, increase the soil moisture and shoot growth in this case. The H2Flo was applied via the drip irrigation. Again, there was 2 irrigation programs, this time 100% and 80%. And the H2Flo was applied at a very similar rate, so it's 1.2 litres a hectare at the start, and then 1.2 litres a hectare at 4, 8 and 12 weeks. So there was an equivalent of 4.8 litres applied, and that was over a period of from June to September. Again, we looked at the soil moisture. So this was taken at 20 centimetre deep with the TDR, so the same moisture meter as before. And it was taken again before the first irrigation cycle each morning. And we took 2 distances, so we took 60 centimetres and 120 centimetres away from the tree trunk. So this was really to show you if and how the water was moving sideways away from the drip emitter, which was next to the trunk. And then we also looked at the number of new shoots, so this was just a count of new shoots per half the tree, and this count was done in October. And again, the best treatment result from this was we showed a 14% increase in shoot growth, and we were able to offer a 20% water saving. And in terms of return on investment, we didn't look at yield in this case because the trial is still running. But again, we had a similar cost, so 96 euros per hectare. But the pumping cost for running this particular crop for the 120 days, it worked out at 8.88 euros per hour, and it needed to be run for 260 hours. So you had a total cost there of 2,309 euros. So a 20% saving on this cost is equivalent to 462 euros a hectare. So there is a big saving just on the pumping, the electricity, the diesel, gasoline cost of running the pumping station. And this doesn't include paying for any water. So this is assuming the water is free, but you need to pay for the costs of the irrigation system. So you can see here that the costs are very large for this type of operation, so that any sort of savings can easily pay for the cost of using the H2Flo. This first one shows you the average moisture 60 centimeters from the trunk. Obviously, it's fairly clear here. You can see there's a large increase, 60 centimeters from the trunk, with the H2Flo versus the untreated 100%. So even though you're putting on 20% less water, you're moving that water a lot further from the base of the trunk. You're getting a much larger area covered with your water. And the difference are even more clear as you move further away. So this is at 120 centimeters from the trunk, and you can see here there's a very low percentage of moisture with the non-treated 100%, but that's increased a lot with the 80% water and H2Flo. So you can see that you clearly hear that the H2Flo is moving the water in a much larger, wider area away from the base of the trunk. And this is obviously important because it means that the roots will follow the water. You're not just going straight down with the water. You're not just got a single small area of roots. You've got a much larger area of roots which can take up a lot more nutrient from the soil. And we can see that there was a significant and a clear increase in the number of new shoots per half tree. So you can see here that the non-treated was running at around 58 new shoots per half tree, whereas with the H2Flo on only 20 and only 80%, we were up to the 65. So more work is required on this one to translate these new shoots into yield data. But obviously this is a longer-term crop, and this trial will continue to run. But I think it's very interesting and very clear. This shows how H2Flo moves water laterally. The last trial to go through now is a tomato trial taken from spring 2014. And these photos just show you, again, the trial site. So you can see you've got 100% irrigation with no soil surfactant. You've got 75% with no soil surfactant, and 75% with the H2Flo. And what you can see on this central picture here is that it looks very similar to the 100%. So there's 25% water less, but the actual crop looks very similar. If you compare this with the 75% and no H2Flo, you can clearly see that the crop isn't growing as large, because you can see all of the support posts, which you can't see on either the 100% or the 75%. So this variety that we were looking at was a charger variety of tomato. It's a commercial field trial. The tomato plants were in single rows, 1 drip tape per plot. We looked at 3 irrigation programs here. So we looked at 100%, 75%, and 50%. So we went all the way down to 50% to see how far down we could go. And the H2Flo in this case was applied at 1.2 litres a hectare at 0, so 0 weeks after transplanting, and then it was applied at the 0.6 litres a hectare rate at weeks 1, 3, 5, and 7. So there's 3.6 litres in total. We were looking at the soil volumetric water content, so that's the moisture content at 15 centimetre depth and 15 centimetres from the edge. We were looking at plant height, we were looking at foliar biomass, and the key obviously here was we were looking at the marketable yields at 10 and 12 weeks after transplanting. So our best result here was that we managed to maintain the yield, so the yield was the same as with the 100% irrigation, with a 25% water saving. And this was actually equivalent with this crop to over 1 million litres per hectare of water saved. So there was a positive return on investment of almost 400 euros per hectare, just based on the energy, the pumping savings from using 25% less irrigation. And this slide shows you very clearly what's happening. So this is the fruit weight kilograms per hectare total. You can see with 100% irrigation, no H2Flo, you're running at this level, so 20,600. As soon as you start to drop the water, so this is down at now 75% and then down to 50, you can see a very clear correlation and a drop in the yield of the crop. However, if we move over and look at the H2Flo columns, you can see that with 75%, we've got very close, so statistically the same as the 100%. So there's a 25% saving in water, no real change in yield. The 50%, we didn't manage to maintain the full amount of yield, but you can see that there was a very large increase versus the untreated. And this is significant in crops where the amount of water is controlled, so they have no choice but to cut the water rate, so they might only be able to use half the water. And this difference here, this 14,000 versus this almost 7,000, could be the difference between making a crop viable or not. So if you have to cut your water by a very large amount, then H2Flo can still make your crop viable. But a 25%, somewhere between 25 and 30% saving, it will actually allow you to maintain the 100% yield. So are there any questions at all on the trial section?
Gary, there are, let's say, a few questions, not specifically on the trial section, but there is a question from Anita Gunnarsson. What about H2Flo use in organic farming? Can you explain something on that?
Yes, H2Flo is not a organic product, it's synthetic chemistry, so it wouldn't be, in its current form, it wouldn't be approved for use on organic systems.
Okay. One other question is about the mixability with pesticides. Can it be combined with various pesticides?
It can be, but we don't have the product registered as an adjuvant. So in markets where an adjuvant registration is required, we can't make that recommendation. However, from a chemistry point of view, there's no reason why it cannot be applied at the same time if there are no restrictions in terms of registration.
Okay. There are quite a few questions, Gary, from various people about the use of H2Flo via a pivot system. We presented here mainly as a product which is applied via fertigation.
Sure.
Can you explain if it can be used on pivots or on boom sprayers?
Yes, it can be applied both in both those applications. So we've actually done quite a lot of work applying the product on center pivots, mainly in Texas, on cotton crops. So the same application rate is used, so it's still the 1.2 to 2.4 litres per hectare. Usually with the center pivot, we'd go at the higher rate for the initial application, and it's the same monthly application. So we've done a lot of work to show you that the product's safe to use. It's okay to be applied foliar. It doesn't need to be applied directly to the soil. You want to get the product into the soil, into the root zone to work, but it's safe to be applied to the plant leaves themselves. And the same thing with a boom sprayer. So again, we've done work with this, and you can get recommendations for applications with a boom sprayer where you don't have a irrigation system. And we're looking at trying to do more work this year on different types of crops using that particular application.
Yes, there is one other question. You show here some crops. What are the plans to test the H2Flo on other crops? And before you give answer, Gary, the way of applying H2Flo via boom sprayers, via pivots, we did in 2015 a very good trial in Sweden with very good results on potatoes. And we have a trial information sheet on that specific crop product combination in Sweden, which we can send out to all the participants after this call. Yeah. So coming back, Gary, potatoes is one of the other crops where we have tested it. Perhaps can you explain what the plans are for 2016 to start trials on which other crops?
Sure, yeah. We've already got trials on peppers, melons, and grapes, and onions. And then this year we've got plans to expand the trial, so we'll be looking at a lot more different types of crops. So if there's a specific crop that you want to test, then we can get that underway. So what we plan to do this year is try and really expand the application away from just the drip irrigation, so we can look at the field crops or the non-irrigated crops in a lot more detail. Okay.
I have one question from Holland, Gary, where they ask, is it necessary to use 1,000 liters of water when using a boom sprayer? Or is it possible to use less water if you apply it via boom sprayers?
Well, I think we, for the time being, I think we need to keep to that high water rate because we don't have the work or the data to show that we can use a lower rate, and we definitely do have the data to show it works at that high rate. The water there is really there to ensure that we get coverage over the field.
Okay. We have a question from Andrew Koch from the UK. Andrew, you are unmuted now. He asked, does it increase persistency of residual pesticides, which could create problems with regard to harvest intervals?
No, it doesn't. We've done quite a lot of work combining the product with, or putting on at the same time or prior to the pesticides and herbicides. We found an increase in the efficacy short term, but the product is fully biodegradable, and it biodegrades within 30 to 60 days within the soil, and it's safe to use on food crops.
Okay. Gary, I suggest we continue.
We're
also looking at the time. Other questions can be asked later at the end of the presentation.
Sure. I think we're nearly there now anyway. So this is a point that was just covered on the question here. So the interaction with soil-applied pesticides and herbicides. So as I explained, H2Flo does not have a adjuvant registration. This might be something we do in the future, but currently it doesn't. So it shouldn't be tank mixed or applied at the same time with soil-applied pesticides. One of the concerns that was raised earlier is that to do with flushing or moving pre-emergent herbicides. Now, H2Flo doesn't have a strong penetrant action. You saw from the dye slide that it was much more of a sideways movement. So it's not a type of product that's going to flush or push out or move the pre-emergent herbicides away from the soil. It can be applied prior to application of a pesticide or herbicide, and we've done some work with a fumigant company looking at methamphotassium. So here they actually use the H2Flo during the pre-phase, so when they actually wet the beds up before they then apply the methamphotassium through the drip system. And they found far better results on the edges of the beds, so where they had weed growth that they wanted to remove using the metam, the application of H2Flo before it allows the sides or the corners or the edges of the bed to become wet. Once they're wet, that means the fumigant part can be active and can work. So there is examples of where it can be beneficial to use the two things together. Crop safety, a very important point. So tested extensively for phytotoxicity, and we've had no issues found, even at far higher than the application rates stated, so up to 8 times application rates with no issues. This isn't a brand new product. We have been using it commercially already for a number of years in the UK and the US. So commercially it's been used so far: strawberries, tomatoes, peppers, melons, cotton I mentioned, potatoes, different types of fruit trees, olives. There's more work going on in this area. Lettuces, again, an area where there's more work going on this year, and carrots. So there's been over 3 years of commercial use of product. We've had no issues of crop damage or negative effects on yield or crop quality. And so far, everyone who's used the product has liked the product. They've gone back and used it again, or they've expanded the area that they want to treat. So we see it being a product that you need to use, try, see for yourself. And once you do, then the opportunities really start to open up. Chemical safety, obviously, also very important. So the product's fully biodegradable. It meets the EC requirements on biodegradability. It doesn't require a hazard warning on the label. It's a non-hazardous material, which is obviously important for shipping and moving around. It has a neutral pH of around 7, so that's another one of the key reasons why it's compatible with a lot of different fertilizer chemistries, and it's not going to cause you any issues with altering your soil or water pH. This is just the label here, so this is what will actually be appearing on the bottles. We're packaging the product into 5-litre bottles, so it's 4 by 5, so 4 bottles or cans in a box, and then there's 40 boxes per pallet. And the reverse label has all the application rates on there. Hopefully, it should be very clear on how to use. An important point that was raised was on the shelf life. So we put on there as standard a 2-year shelf life. Now it'll be at least as long as that. There's no reason why the chemistry will degrade even for a longer period than that. But a 2 years is the standard amount on there. And I know that there is some products in the marketplace that are used that have a limited shelf life, maybe only up to 6 months or 1 year. So this can be an advantage for H2Flo. So we're coming to the end now. So the 1-minute message, what I really want everyone to take away from this is that H2Flo, it's a way of saving water and therefore saving money while maintaining or even increasing your yield. So we can make claims of 25% water savings, and we're comfortable with supporting that. There's savings on pumping costs, so the pumping costs alone can more than cover the cost of the product, even before you get into yield. This is an improved formulation building on several years of extensive lab, university, and field testing. We've been working on this type of product now for over 6 years at ICL, so this is the current newest generation of the product. The benefits aren't restricted solely to sandy soil, although this will be your initial target market. And the untreated hectare is the key part here. So you're not necessarily replacing or adding a product in that's already there. You're doing something that isn't being done. So the grower needs to be convinced on this type of application. But once they are, there's a very large potential for this type of product. All the crops we've treated so far have responded very well, and as mentioned, we've got an ongoing research and trial plan for 2016 and beyond. There will be a full research technical seminar planned, which my colleague Dr. Neil Baldwin will be doing sometime in the spring. So again, that will be a more in-depth look at the technical side of the product. We've got at least 6 or 7 trials planned for 2016, and I'm sure there'll be a lot more as well. So I want to thank you for listening and open the floor up for questions, please.
Yeah, Gary, one of the questions is, sounds quite simple, but I think it's a very good question. What to do if suddenly there is more water, more rainwater, or more, let's say, irrigation water suddenly? Do you then get an issue with H2Flo?
No, you won't have problems with it pooling on the surface, and you know the water will move away. So although I mentioned that there wasn't a strong penetrant in there, there's still penetrant on there. So if you've got surface water, adding H2Flo will help that water move away. If it's a rainfall event, then obviously there's not much you can do to control the amount of water. If it's irrigation, then you need to turn your irrigation system down, which again sounds obvious, but we have had end users using the product, and we've told them, look, there's a 25% saving, and they've just used their full irrigation system, and they've ended up with more water than they need, or the water running off because they're putting excess water on.
Okay. One other question which comes back a few times is, can you explain a little bit more what the root activator actually does and what it is?
Yeah, okay, so the root activator it's not actually a biostimulant in its own right, it's actually a surfactant system, and the way this surfactant system is, it sits in the soil particles, and it covers the roots. And there's more work being done into this area to show exactly why and how it works. But what we think happens is that it allows for a better ratio of the air, water within the soil, and this allows those finer root hairs to grow. So water isn't sitting close to and around the plant all the time. It's not always saturated, and having that air and the air movement means that these small root hairs can grow and expand into that area.
Okay. One other question is from Anita Gunnarsson. Are there any scientific publications on this specific surfactant or on surfactants in general?
I believe that there's quite a lot of publications on surfactants in general. There isn't any currently on the H2Flo, but I'm sure there will be in the future as more and more research is done. For example, there's a 3-year project running in Israel at the moment, a very large project which is going to be yielding a lot of different types of data, and I'm sure that will be something that will be published.
Okay. One other question, Gary, from Italy. Luigi Parlato is asking this. Is it possible to use H2Flo in nursery in pots with average diameter of 14 centimeters to improve water and root distribution when we have drip irrigation in the pot? Question, of course, is do you need in such a small pot H2Flo? But can you elaborate on that?
Yes, you can use it for that application. We do have a specific product which is more for the media application, which is H2Grow, and that has a much longer residual effect. So that goes up to 90 days plus. So if they want to make a single application in a pot, then H2Grow might be a better product than H2Flo. However, if they're using it for a short period, so if they are looking at a 30-day period, say, then H2Flo through the drip system can be a good application.
Okay. One other question from Jason Tan. We spoke about the efficiency of H2Flo on fertilizer, but what Jason actually is asking, is it possible to save fertilizer costs when using H2Flo?
Really good question. The answer is almost certainly yes, but currently we don't know how much. So we're working this year on a whole raft of trials where we're going to have using controlled lysimeters, looking at the fertilizer applied, looking at reducing fertilizer rates. Obviously, at the moment, what we say is keep the fertilizer rates at the full amount and just look to try and increase the yield. But really, there will be opportunities to be able to make reductions in fertilizers, but we need to do more work in this area to be able to actually quantify it. And I think it'll be hard because it'll depend on the soil type, the crop. So giving a generalized answer will be difficult, and I think it will have to be down to experience in the field, where maybe the first time it's applied, fertilizer rates are kept as they are, and yield and everything else is monitored, and then going forward, then maybe then it can start to be looked at and the fertilizer rates altered if needed.
Yeah. I think ultimately increasing yield is nice, but also if we can indeed reduce fertilizer input, that would be a great achievement. But that's something we need to look more closely to. I already mentioned the information on the trial in Sweden, so we can send that to all the participants of this webinar. There is another question if we can get the more complete trial data on the tomato trial. So please ask your local ICL area sales manager if you have still any questions about this webinar or you want to know more details of a specific trial. We are happy to share that with you, so contact us and we can give you more details on such a trial. Yeah. I think Gary, if I look at the questions, we asked most of that. I still have one question from Andrew from the UK, and the question is: considering the non-flush outcome mentioned regarding herbicides, would the recommendation for use in a mixture with a product that is intended to penetrate the root zone to put H2Flo with the actual product or before the product is applied?
Ideally, you'd be wanting it to put it before the product is applied.
That gives the best outcome, you say?
Yeah.
Okay. I'm not seeing any more questions popping up, everybody. So if this is the final question at this moment, then I think we are very nice within our time frame. It's a little bit past 11. So I would like to thank everybody for the participation and for your time to attend this call. I would like to thank Gary for the very good explanation on H2Flo. If there are still any specific questions, feel free to contact your local ASM or contact us directly via an email or via a telephone call. So once again, thanks everybody for your time. Thanks for all the questions and the interest in this nice product. And you will see a next invitation for a technical webinar coming soon in your mailbox. Thanks and have a very good weekend.